Good morning, dear participants. We'll wait for some more minutes. I think we can start now.
Yes,
Over
sir.
to
We
you,
can
sir.
start, sir.
Okay.
Shall we start, sir?
Yes, sir,
Yes, sir.
please.
Please go ahead.
So, good morning, everyone. For the fourth day of our online skill development certificate course, I hope you have finding the sessions insightful and enriching. Today, we have another exciting presentation lined up for you. Before we dive into today's topic, I am thrilled to introduce our esteemed speaker who bring a wealth of knowledge and experience to our program. It is an honor to introduce Dr. Anurag Maurya, an academician and researcher whose work bridges the field of botany, environmental science, nanotechnology, and biomedical applications. Dr. Maurya is currently serving as an assistant professor in the Department of Botany at Shivaji College, University of Delhi, a position he held since 2016. Over the past several years, he has demonstrated a deep commitment to teaching, research, and academic leadership. Dr. Maurya earned his MPhil and PhD from the School of Environmental Science at JNU, New Delhi, and MSc in Botany from Banaras Hindu University, BHU. He has qualified several prestigious national level examinations, including CSIR, NET, JRF, GATE, and ICMR JRF, securing top rank that reflect his academic excellence. His interdisciplinary research spans plant biotechnology, cell biology, toxicology, and environmental monitoring. Dr. Maurya has authored and co-authored multiple research articles in internationally reputed journals. In addition to research, Dr. Maurya has contributed significantly to academic development and student training. He has been involved in teaching a wide range of undergraduate courses, including biostatistics, plant physiology, environmental microbiology, and molecular biology. He had served as a resource person for DBT sponsored training program, DST Inspire camps, and summer workshop for school and undergraduate students. Dr. Maurya's dedication extends beyond academics. He has been an active member of several college committees. He has organized and coordinated educational visits, hands-on workshop, and student enrichment program, always striving to inspire and mentor young minds. With a balanced blend of research rigor, teaching dedication, and institutional engagement, Dr. Maurya exemplifies the role of an academic who not only contribute knowledge but also cultivate a vibrant and informed student community. I welcome you once again, Dr. Anurag Maurya. Over to you, sir.
Good morning, sir. Thank you for a very nice introduction. Thank you for inviting me to this very much program. And I would like to begin with thanking the convener of this uh, SLDC, Dr. Saima, Dr. Savinder, and Dr. Jishanur Rahman, coordinator for this course. And I would like to share my screen. Just let me know if it is visible.
It's visible, sir.
Okay. Thank you. So I'm delighted to be part of this program. The topic I have to cover is the classification of data. So, dear participants, I hope you must have been introduced with the data. But I will begin with the definition of the data and basic concept of that. Maybe you will get some other perspective if you have studied it earlier. Though the popular term is data, but sometimes the singular form of that we call it datum. And it is very basic part, or you can say the statistics deals with the data only, and statistics begins with the data and it ends up with the data. It begins with the basic information collected from the ground, collected from the field, that is called as the data, and the inference you often get in the form of data only. And the data is measured or counted fact or piece of information. Here you must note that it is either counted or it is measured. And we will see why is it relevant and why we must emphasize these two terms. And in plural, we call it data, and we can call it statistics also. And you must be learning that statistics term is used in multiple way. It reflects the data itself. It reflects the inference you derive from the data by applying the statistical tool, and the methodology of analyzing these data points, that is also called as statistics. So we are calling datum or the singular form as statistic and the plural form, that is data, as statistics. So statistical data is a set of facts, because we are calling it plural, so it is set of facts about an attribute or character expressed in quantitative, qualitative, or numerical form. The definition you might not get here, but we will see with some example and illustration, then you will get it. Often, when we go through the method of statistics, we usually try to find an insight about a set of individual residing in a particular setup or in a particular area, or or in an experimental plan. The set of individual which you want to study is called as population, as it is represented here in this circle. These are all the individuals. Suppose if you want to study all of them, then one example can be the population of Delhi or a district of Delhi. Okay, that would be called as population in statistics. But the purpose of statistics is to derive the inference, not by studying all the individual from which we seek the information or the inference. Rather, we take a small set of individual from that population and we derive inference for the complete set of individual. And that small set of individual taken from the population as representative is called as sample. And this process of selecting the individual from the population is called as sampling. Okay. And from that sample, you will have to study each and every individual. Okay. Yes. Okay. 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 Let me reshare it. Is it visible now? Okay. Okay. Thank you. So I will revise that again. Here in this circle, the population is represented, and small set of individual which has been taken from this particular population is called as sample. And from in the sample, we are intended to study each and every individual. These individual can be called as observational units or subject. When we are trying to collect the data, actually we seek to collect the information from each and every individual which has come into the sample. It happens usually we collect the data from the sample only. So, and For each individual, we now have to select what kind of character we want to study. For example, we want to study the height of each and every individual in this, or we might want to certain health indicators, suppose BMI of each and every individual. Okay, so these characteristics are called as variables, or sometimes we call it as attribute. And when we are measuring this variable which we have selected, and we are getting some information after measuring that particular attribute, that is called as data. And sometimes just counting things can also become the data. For example, you are counting uh, maybe the number of individual in different samples, that can be a kind of data. So either you're counting something, that would be the data, or you're measuring something, that would also be the data. Or suppose you are measuring the weight of individual, that would be also a kind of data. So here you're seeing that after you have selected the sample from the population, then you have selected the characteristics which you want to study. The characteristics can be of uh, can also be of different type. Like there can be constant. The constant means the characteristic which is not varying from one individual to another. Like if you call, if in this sample all are humans, so if you try to find out what kind of individuals are there, or what species of individuals are there in this population, then all are humans. So that particular that species, if you call it variable or characteristic, that is going to remain constant. And then there are variable which are varying from one individual to another in the sample. Here, height or weight can be the variable for this given sample. Okay, so we have decided population, then we have decided sample, then we have decided characteristics or variable, and then we are measuring or counting it to get the data for each and every individual. This is very brief of the process before collecting a data from a particular population. Okay, so first you decide the population. For example, you are deciding that you want to know the birth rate in a particular month in this hospitals of South Delhi district. So the individual or the ladies we are coming for the birth in the hospitals in South Delhi, that can be the population in that particular case. But you are, suppose you are not going to each and every hospital. You are studying only the selected hospitals. That selected hospital will become the sample. Okay, and in that selected hospitals, you are studying each and every birth happening there, and you are counting that. So that count in hospital will become the data. But data is not just limited to individual. Data can be of the sample, like the birth rate in a given month for a hospital. Okay, and hospital is a sample. Then that data or the average birth rate can also be the kind of data. Or if you are getting the idea about the whole South Delhi, okay, then you are getting the data about the population. So as I was saying in the beginning, you are starting with the data and you are ending with the data. And then, of course, you are getting some inference based on your uh, other information you're having about the population. And in this process, the first step is the collection of data. First, you are collecting the data. Suppose you went to the hospital and you are just noting down whatever coming on your way. Okay, you stayed in hospital maybe for a month, and all throughout the day and all throughout the month you kept on noting down the births. Okay, and then this data might not give you the information about what is the birth rate according to the economic class of the individual. Okay, or maybe the patients coming from different regions to the hospital. So after collecting, you will first classify the data. For example, uh, the birth rate in women coming from different economic class like poor, lower middle class, or middle class, or upper middle class. Okay, if you want to get information in that way, then you will have to first classify the data, and then you will present the data, then analyze the data, interpretation, then inference. We are not going through all that process, but what I'm trying to convey from this slide is that these are this is the basic process of the collecting data and getting the inference, or the methodology of statistics. And classification is one step of that process, and we will discuss the classification today. So coming to the classification, I hope you must have got some idea about the data and how we are going through the data while we are performing the statistics. So classification of data is a process of organizing raw data into meaningful categories or groups. Simply, it is categorization of data into different groups based on certain characteristics. Certainly, the individual in a particular group will be having similarity, and in different groups would be different on certain basis. For example, in this diagram, in this picture, you can see these are the groups, these are the individuals in a sample or in a population. We are classifying them in different age groups. On the left side, you are seeing the elderly people. In the middle one, you are seeing the youth, and you're seeing the kids in the rightmost group. So here we are classifying the data based on their age group. So you're seeing that in each group there would be certain similarity, and and the different group would be different on that particular basis. Moreover, you can see here again that there could be many bases of grouping this particular set of individuals. Here we have classified them based on their age, but the same group can be the same individuals can be classified based on their economic class, based on the kind of the color of their dresses, according to the information you are seeking set of individual. So why I'm saying this, by classifying the individuals on different bases, you can get different kind of information from the same set of individuals. Okay, and that is why classification is very much necessary. If you classify it, you can get the information which you apparently not get. This is another example. Here you are seeing a raw data. Raw data means the one which have been just collected and it has not yet been classified or even arranged. Here you are seeing that the 100 individuals had been sorted with fruits. Like the first individual has been sorted with orange, second with banana, third with orange again, then fourth banana, then fifth mango and orange, and this so on. So whenever you will collect the data directly from the source, it will come like this, like a raw array of data. But you cannot get any information from here. So first you need to classify it. And here the basis of classification would be the kind of uh, the that has been served. And after classifying, you will get this. After classifying, you are seeing that 29 people, 29 individuals were served with mango, 24 with apple, 19 with banana, 15 with grapes, and 13 with orange. So you can easily see the significance of classification here. Earlier, it was not giving any information, though it was there. But now, after classification, you are able to see it. One more thing I want to emphasize here, that classification and tabulation goes hand in hand. Okay? As you are classifying it, at the same time, you will be preparing the table also. So we are here with significance of classification of data. Why do we perform the classification? Okay, and one sample, one example you have seen here, and so that then you can easily get it. So often there is an overwhelming mass of raw data without any structure, which you can see here. This raw data doesn't have any structure. Unorganized data are not fit for further analysis and interpretation. Okay, without classifying, this raw data cannot be analyzed, neither you can get any interpretation from here. In order to make the data simple and easily understandable, the first task is to condense and simplify them in such a way that irrelevant data are removed and significant figures are stand out prominently. It helps in simplifying, analyzing, interpreting, and presenting data effectively. So here you can see that once it has been organized into this particular table, we call it frequency table, the data has been condensed and it has been simplified. And even it can be analyzed further also. It can the data can be compared, and other analysis it can be done. So first significance is that the data has been simplified, as you could see there, and the condensed data, condensation of data, voluminous data. Voluminous means it was huge here. It was overwhelming. You were not able to get anything out of it. But when it is in this particular form, you can get it. Another example you can see in this table, that the number of the students in a class has been classified based on their marks. For example, the 3 students got marks between 0 to 20, 7 students got the marks between 21 to 40, 15 students got marks between 41 to 60, and so on. It facilitates comparison. In this particular example, you can see in first lot, 100 fruits were served, and in second serving, they were again served the similar kind of fruits, but the numbers are different. In first serving, 29 individual got mango, but in second serving, 34 got the mango, and so on. So you know that as you got the raw data in the first serving, in the second serving also again you will get the raw data in similar form, but you cannot compare the two raw data. But when they are organized, when they are classified, it can be compared. So you can see that once the data has been classified, the two sets of data can be compared, and other inferences can also be drawn out from if it is classified. Further, it adds to the statistical analysis. Like you can prepare frequency table, you can prepare graph and charts, you can do summary statistics, and so on. For example, here you can see the same table has been drawn into bar diagram. Mango was served to 29 and 34 individuals in first serving and second serving. Here, the bar diagram is showing the same. In first serving, represented by the blue column, is showing 29 individual, and in second serving, represented by the another column, showing 34 individuals served with the mango in second serving. And classification is the foundation of tabulation and presentation. As I told you that classification and tabulation goes hand in hand. And the next step is the presentation of data through bar and chart, etc., etc. So classification, after collection of the data, the classification and tabulation is the first step for anything. So after classification, you can see the pattern and trends. As you could see the trend here through the bar diagram, and it saves time and effort. Of course, when it is organized, the effort for the next step will be lesser. Next, we will deal with some confusing term. Means you will get some terms like quantitative data and qualitative data when you will study the types of data, or some nominal data and ordinal data you will get when you are doing this, when you are studying the scale of data. And all these terms you will get when you will study the classification of data also. So to remove that confusion, we will see in brief those terms. So first we are seeing types versus classification of data. So first see what do I mean by types? Types refers to basic nature or form of the data in which data exists. For example, qualitative data and quantitative data. As the name itself suggests, qualitative means the data represents or depicts the quality of individual. For example, gender. Like if you're saying a person is male or female, that means you are saying the quality. Or if you are saying the educational level, that is the quality of individual. Okay. Similarly, quantitative data, here the data is representing the quantity of individual. For example, weight of particular individual or height of particular individual. Quantitative data can be discrete or continuous. Discrete means the individual or the information can be counted as 1, 2, 3 in integers. Okay, like number of fingers or number of toes in the foot. Okay, and there is continuous data which has to be measured, and it can adopt number as integer or non-integers, like the weight can be 1.2.5 kg. Okay, but number of hands will always be 2, or number of leaf in a plant would always be 1 or 2 or 3 or 5. It cannot be 1.5. So the attribute or the variable which are counted in integers only are called as discrete data, and those who can the quantity which can be measured, not counted, uh, are called as continuous data. Now the qualitative data can be nominal or ordinal. Nominal where it can be named only, like male or female. Ordinal means it can be graded in certain order, like you are in the kid is in first standard, then or second standard or third standard. And why am I putting here? When you do the classification of data, again you will face the similar term, qualitative and quantitative. Okay, there it becomes the basis of classification. The nature of data becomes the basis of classification of data. Okay, so here from this table you can again try to infer What is the difference between types of data and classification of data? Types means to the nature or format of the data itself. And while you are classifying, the same nature of the data becomes the basis of grouping the data into subgroups. Okay, this much you should get from here, not more than that. And another is types versus classification scale of data. Now, I hope you must have studied scale before, scale of the data. But in very brief, I would like to explain here.
No,
There
sir.
are
It would be better if you will briefly explain.
okay. Right. So, as we have discussed in brief, that there are two kind of data based on their nature, qualitative and quantitative. Similarly, there are four levels of measurement of data. In first way, we can just name the data, like blood group A, B, AB, or O. You cannot order it. You cannot say that B is better than A blood group or AB is better than B or O. You cannot find any order. You can just name it like male and female. The gender is male or female or other gender which has come into the picture. But you cannot order them into certain particular series. This kind of scale is called as nominal scale. As the name suggests, nominal means naming. Then there is ordinal scale. Here you can order them into particular series like like movie rating, good, better, or best. Movie was good or better or best. Or um, we used to order individual in usually we used to teacher used to mark in the notebook of kids that the performance was poor or it was good or it was better. You also used to rate things on the basis of star, like 1 star, 2 star, 3 star, 4 star, and 5. That is kind of ordinal scale. You are not giving any number. Even if you're giving the number, that doesn't hold the exact value. Why is it so? We will discuss that. Like if you are rating certain material as 1 star and the other as 2 star and the other as 3 star, the difference of quality between 1 star and 2 star will not be the same as the difference between 2 star and 3 star in terms of the quality of material. That means the interval between 1 and 2 and 3 is not the same. Okay, if interval is not the same, but we can order things in certain particular series in increasing or decreasing, then that scale is called as ordinal. Now you must differentiate here that you cannot order AB, and O blood group, but you can order good, better, and best. Okay, this is how nominal and ordinal are different from each other. Now consider interval scale. Here you can order it, but the intervals are also remaining the same between consecutive marking points. For example, the temperature in Celsius. Take an example, you are heating 1 liter of water, giving it certain amount of heat. The amount of heat you will give to the water, 1 liter water, to raise it from 20 degrees Celsius to 21 degrees Celsius will take 1 calorie of heat. And from 21 to 22, it will again take 1 calorie of heat. Then again 22 to 23, 1 calorie of heat. And so on. That means the difference between 20 to 21 and 21 to 22, 22 to 23 remains the same in terms of the heat requirement to raise the temperature. But here, the zero is not absolute. What does it mean? Zero doesn't mean nothing. If the temperature of water is 0 degrees Celsius, it doesn't mean that it doesn't have heat. Suppose you are extracting the heat from water. Water was at 5 degrees Celsius. You started taking out of the heat, and temperature went down from 5 to 4, 4 to 3, 3 to 2, and 2 to 1, and then 0. You can even take the heat from 0 degrees Celsius. If you take out the heat from 0, it will go -1, -2, -3, and so on, up to -273 degrees Celsius. Okay, so here in degree Celsius scale, the interval remains the same between two consecutive points, but the 0 is not absolute. 0 doesn't mean anything. But if I suppose I'm saying the height is 0 of something, that means it doesn't have any dimension. Okay, so height, which you are measuring in terms of meter or centimeter or millimeter and micrometer and so on, here this scale is having an absolute 0. But this degree Celsius scale doesn't have any absolute 0. So the scale which has the interval similar to interval scale, but also has meaningful or absolute 0, that is called as ratio scale. So again, I'm reviewing the same. Nominal scale means naming, no order. Ordinal scale means naming as well as ordering it, but no same interval between two consecutive points. Interval means intervals are remaining the same in two consecutive points, but 0 is not absolute. And ratio means it also has the meaningful or absolute 0, like height, weight, and income. If somebody has 0 income, it means that that person is not earning anything. The same is represented here. Now, why scale and classification is being discussed here? Because you just saw that nominal and ordinal came here while we were discussing the types of data. This could be the basis of classification of data also. Like you can, like there can be different categories. Categories also nominal data. Like you are saying that banana, the different kind of fruits which we just discussed are actually nominal scale, are measured on the nominal scale. Like here you're seeing mango, apple, banana, grapes, orange. They are actually measured on nominal scale. We cannot order mango, apple, banana, and grapes and orange. So these are actually the fruits. The naming of fruits is actually on the nominal scale, but their count are actually on ratio scale. So scale also comes while we discuss the classification of data. Types also comes when we discuss the classification of data. Now we are coming to the methods of classification of data. This is a very general way of classifying it. First, you need to understand the nature of data, whether it is qualitative or quantitative. Then decide what is the scale of data. Actually, you will have to decide when you are going to collect it itself. Before even classification, you must know the nature of data and the measurement scale. Measurement, whether this is nominal or ordinal, interval or ratio. But you must keep that information intact when you are going to classify it. Okay, so before collection you must know all these information, and the same information will be required for classification. Now you must know the objective of classification of data. As I told, that the same group of individual can be classified on different basis based on what kind of inference we want to seek, we want to have at the end. As you just saw that the group of individual here, group of individual can be classified in different ways. So before classification even, you must know on what basis you are going to classify. And and how would you decide the basis of classification? it will be it will rely on the kind of inference you want to get after doing the classification. So you need to define the objective of classification. You want to do comparison, you want to do trend analysis, or you want to do regional study. And accordingly, you will change the basis of classification. And once the objective has been decided, you will decide what would be the basis of classification. Depending on your data, choose one or more of the following methods. Methods or basis. Now we are coming to the basis of classification. The basis of classification of data can be majorly, it can be quantitative, qualitative, chronological, or geographical. As you just saw, as we just discussed about the type of data, we are seeing the term again, quantitative and qualitative. And this quantitative can be simple classification or manifold. Quantitative can be discrete or continuous. All these we are going to discuss in detail. This is actually main body of the classification of data which we have to discuss. So first we are discussing in brief the chronological versus geographical classification. Chronological or temporal classification, for this kind of classification, time is the basis. On, on the basis of time, you are going to classify the data. For example, here, year can be the basis, means in which year the data has been collected, or month can be the basis, in which month it has been collected, or days, etc. Or even the hours and second can also be the basis. It is used for time series analysis or trend analysis. Geographical or spatial classification, it is based on the location, like geographical areas like countries, cities, states, or even regions, like something from Himalayas and something from Vindhyan Range. It is used for regional analysis, market segmentation, etc. For example, literacy rate in Kerala is 96.2 and in Bihar it is 70.2, 70.9. Here for chronological example is suppose the revenue was 5 lakh in 2020 and 6 lakh in 2021. Qualitative and quantitative basis of classification. If the data is qualitative, then it would be qualitative classification. As we just saw, mango, apple, banana, as we are seeing from the beginning, it is the classification based on the quality of the apple. The other example is gender, religion, or occupation. This could be the basis of qualitative classification of the data. Similarly, quantitative classification based on the numerical value. Numerical value means the magnitude of the individual, magnitude like height of the individual or the number gained, the marks gained in particular exam. So numerical data is grouped into the class interval or categories, and it is making the frequency distribution table, as we have discussed about the marks of the individual. And marks could be the basis of classification of the data. So first we are going to discuss in detail the chronological classification of data. So chronological classification is a method of organizing data according to time, such as years, months, days, decades, or any time related sequence, even hours, or like suppose cricket game is going on, so how many runs were scored in first hour of the match and how many in second and third and so on. So that could also be the basis. It helps in studying how data changes or trends over time, and essential for time series analysis. The time interval can be uniform or irregular, like um, like the development of a particular country or the economic growth of the country in last 50 years, and then in last 20 years, then in last 10 years and 5 years, and 1 year, and so on. So the time interval can be irregular or it can be uniform, like the rainfall in 1991, then 1992, 93, 94, and so on. So time series, that this time interval in which the data is being classified, based on which the data is being classified, can be uniform or it can be irregular. It allows analysts to identify trends, fluctuation, pattern, or seasonality. What does it mean? Trends means suppose you are uh, s- you are collecting the information of the amount of water which is coming in the river Yamuna at the entry of Delhi, okay, or at at the base of Himalaya. When Yamuna is leaving the Himalayan basin, or it is leaving the Himalaya, then you are supposed collecting the information how much water is coming out. And when you'll keep on collecting on year basis, maybe for 100 years, you might get that glacier is melting at faster rate and you are getting more and more water into this. Or suppose you are collecting the information of depth of ice present in particular glacier. Over the years, you might get the information about the thinning of the glacier at a particular site. So this is the trend. Fluctuation means if something is going in particular trend, and suddenly something is suddenly the data is uh, disrupting the trend, that would be called as fluctuation. And pattern is also similar term. You are not bothered about what kind of trend or fluctuation is there. Whatever is happening, you are just collecting as such. That is kind of pattern. Like um, the pattern of your heart rate, okay, and that is giving that will give you the information about the heart health. Then seasonality, and like the the mosquito population is increasing or decreasing based on the season. As the season changes, mosquito population increases or decreases. So all these information are actually based on the time. And when you will classify this information based on the time, you will get all these inferences about trends, fluctuation, patterns, and seasonality. Common timed intervals used is yearly, for example, annual rainfall or annual GDP or population growth. On monthly basis, we usually see monthly sales or monthly temperature or electricity uses. Electricity bill comes more in extreme weather, like in high summer, extreme summer, or extreme winter. Electricity uses increases on monthly basis. Similarly, the sales data is collected on month basis. On daily basis, stock prices, weather condition, or website traffic. These are the example of classification of data based on the time. Here are some numerical examples. Sir, when we have to give for answer session? Okay. Okay. Yes. After finishing maybe the chronological, we can take questions. Okay, end. Okay. Okay. Mm-hmm. Okay. Okay. So this is a numerical example of annual rainfall of data. Here you're seeing from 2019 to 2023, you're having 5 year of data of rainfall. So in the comment you can see this chronological classification carried over 5 years, which can assist in understanding or planning water resources. So it is first decreasing, then increasing, then again decreasing. So you can see the pattern, not very much the increase or decrease. But if you'll see long term data like over decades or over centuries, you can see even the pattern of climate change here. Monthly sale data is here, and this helps to the business analyze seasonal variation in sales and plan inventory or marketing strategies accordingly. For example, the sales of AC uh, would increase in summer months and it will decrease in other months of the year. And this is daily website visitor. Suppose you have certain website related to sales of certain thing, and you are seeing the trend with whether it is increasing or decreasing or whatever happening there. And this will help you to change your strategy of sales. Suppose you are running certain advertisement, and you if you want to see whether the sales are increasing or not. Suppose you have certain shop and uh, mm, you just floated it on Google or Facebook or other social media websites to check if it is having certain effect on your sales or not, and check if it is having certain effect on your sales or not. And then you can see, you would like to see the visitors on your website on daily basis. So importance in real life, in economics, GDP growth over years you can see for business. GDP growth over years you can see for business. You just saw the sales example. For environment, you can see over decades to see whether climate is changing or not. For health, spread of disease over weeks, like we all have seen the COVID, and we were seeing the trends how it is increasing or decreasing. It is line graph, time series chart, or bar graphs. This particular graph you're seeing is the line graph. Here you're seeing over different months certain error, you are seeing what kind of error is happening. So we are seeing how it is increasing or different decreasing over different months. Okay. And here you're seeing in the bottom we have bar graphs, and it is showing project timeline. Like in week 1 we are doing the conceptualization, then in week 2 we are going to do the planning. We are going to finish the planning 100%, and week 3 implementation, week 4 optimization, week 5 execution, week 6 verification and completion and review. So actually it is showing two bars. We are not going into detail, but it is showing, the bars are showing the time series. Then there is time series chart. Here you are seeing the DNA related discovery, how it had happened over the years. Like in 1869, John Frederick Misher first time discovered the nucleic acid, and in 1919, molecular structure of the DNA defined by discovery of ATGC, and then in 1944 found that DNA carries the genetic information, like that means DNA is the genetic material. In 1950, the defined base pairing, like A pairs with the T and G pairs with the C, was discovered. In 1953, the structure of DNA discovered. So this is showing the time series. So these are the different visual representation utilized for chronologically classified data, or the data classified based on the time. Okay. So this is all about the chronological presentation, chronological classification of the data. Next, after the break, we will begin with geographical classification of data. So So shall I begin?
Uh, yes, sir. I think we can begin. So
Okay.
now after this break, we welcome you once again, and now you can start the lecture.
Okay. Is the slide visible?
Yes, sir.
Okay. Okay. Thank you. So now we are going to see how can we classify the data based on the location from where it has been collected, and that is called as geographical or spatial. Spatial means based on the space. Spatial classification of the data. So as you can read here, geographical classification, also called spatial classification, is the method of organizing data based on geographical or regional units such as countries, states, districts, cities, or zones. It helps in understanding how a particular variable varies across different locations or spatial regions. The key feature is location or region is the basis of classification, useful in comparative studies across geographical areas, frequently used in census, environmental studies, business expansion, and policy planning. The common units used is the countries or continents like Asia, Europe, Africa, states or provinces like Uttar Pradesh, Kerala, Maharashtra, cities or towns like Delhi, Mumbai, Chennai, or districts, zones, regions like northern zone, coastal areas. Suppose in district we can see in different districts of Delhi or wards in a particular Delhi district of Delhi. So these can be different localities based on which we will classify the data so that we can see what kind of um, variation is happening based on the space. Like if you're going, suppose if you are considering the average economic status when you are moving from one district to another district of the Delhi. So if so you can get the inference based on the space or based on the districts of Delhi. Or you can see how the rainfall is happening when you are moving from Delhi to eastern UP. So it may vary, and then you can see what is the role of different geographical structure in the rainfall. Suppose one person is moving from Delhi to UP, and another person is moving from Delhi to Rajasthan, and you will see the change in uh, rainfall pattern based on the geography, and that will give you the role of the Aravalli Mountains or the Vindhyam Range or the Himalaya, uh, deciding the amount of rainfall happening in particular region. So this is how classifying the data can help you to derive some inferences. Here is some example. Literacy rate in Indian states. Like you're seeing that these are the different states and these are the literacy rate. And this can help the policymaker decide which particular state is lagging behind in the literacy rate, and they might also correlate it with certain factor in the particular state. Like here you can see that Rajasthan and Bihar are lagging behind in literacy rate, and then policymaker may try to emphasize them or highlight them while making the policy, that there must be certain reason behind the literacy rate in Bihar and Rajasthan, and then they will identify the reason, the, the cause behind that, and then they will make certain policy around that. It is possible only when the data of literacy has been classified based on the states. Similarly, here you can see COVID-19 cases by country in 2020. In India 10 million, USA 20 million, Brazil 7.5 million, UK 5 million. So uh, this will help to identify the reason behind the spread of the disease COVID-19, or this can also help to make the policy to manage the COVID-19 disease, whether it is spread or the vaccine which has to be given to the population. So first example was based on the states, another is by country, the third example is by region. Like in northern India, the wheat production is 95 million tons, in southern India 20 million tons, in eastern it is 15 and western 30. So you can see the largest producer of the wheat is northern India based on this classification. It is possible only when the data is classified based on the region. Okay, and you might find why is it so. Okay, or if you cannot find, at least policy maker will find why the wheat production is used in northern India and lesser in southern and western India, and why it is so less in eastern India. Similarly, the classification based on the city, like the pollution level in different cities, metro cities, Delhi, Mumbai, Bangalore, and Lucknow. So it is useful in planning or even the urban planning. So when you are planning the city, if AQI is already high, then you will plan some green spaces and you will plan the traffic movement around there. You will plan the 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 management methods to handle the particulate matter. So it is you can see how this classification gives some inference, and based on that, the policy maker will make different kind of planning for different kind of cities. Application of geographical classification. Government can take the help of classification of data while allocating the budget. Like as you just saw, the government will allocate more budget for education in the state of Rajasthan and Bihar to improve the literacy rate. Infrastructure development, the state which are having lesser number of cities, smart cities, you can say, um, that state will be given more budget maybe for development of smart cities. Like you know the migratory laborers are more in the states like Uttarakhand or Bihar. So government might plan the infrastructure development in those states, and maybe development of better and smart cities so that employment could be generated in those states. Business market segmentation, like suppose particular company, say say McDonald, the fast food company is having more outlets in Delhi like cities, and they are trying to uh, open their outlets in smaller cities. So they will see for the first they will try to open one or two outlets, and then they will see this the sales rate based on the city, and if the sale is increasing in particular city, then they will increase the number of outlets there. So in this way, this geographical classification of data will help the business persons. Then education, we just gave the example of literacy rate, how the data of literacy rate can help educationists to uh, to make the policies. Even if you have a tech company and you are working very well in mega cities, then you might want to open your branch in the cities where you are having large number of students. For example, one example and I can give, in different kind of tech companies, physics wala gives the education at a lesser price. So physics wala would want to open its branch in the cities where students are in huge number, but they belong to lower middle class or lower class, low income group class. I mean, the information of cities where such kind of students are residing. So they would want to open their branches there. Okay. Similarly, for environment, we have seen the data of AQI. Okay, we see the data of rainfall, we see the data of flood. So based on that, spatial data of flood or EQI or the rainfall, the policy makers which are concerned with the environment, they will make the policy accordingly, including the forest cover. How this kind of spatial data is represented? Few examples are here. However, it is not limited to that. Thematic map, bar graphs, choropleth maps, and pie chart by region. So here you are seeing one map. This is the map of Delhi, and this is showing the population of Delhi by different colors. So here you are seeing that blue is showing very low population, 800 to 10,000 square person per square kilometer, and different color is showing different population density. So the data collected from different region, wards or districts of Delhi is represented over the map by different colors. So this kind of representation of geographically classified data is called as thematic map. Similarly, here you can see on the left side, you can see the same color is with different intensity. It is showing the temperature over different regions of the Delhi. Okay. So here in this particular map, you're seeing different colors. So it is called as thematic map. And here the same color with different intensity has been shown. This kind of map is called as choropleth maps. So this kind of map can only be prepared by only after the classification of data based on the location. First, you have to classify the data based on the location, and then you will be able to prepare this kind of map. And then you can see how the data is giving overall view, which region is warmer and which region is colder. You can see this is the line. This blue line is showing the water body, that is Yamuna, and you can see that along the Yamuna, you are seeing the lower temperature represented by yellowish color, and dark red is showing very warm temperature. Okay.
Sir, excuse me, sir. Sir,
Yes.
this map, blue one is showing the 3D map, right?
Yes.
Uh, yeah,
This is
which
actually
software you are using for
yes,
this,
yes,
the
yes,
visual?
yes. This is actually bar graph. So on the map itself, the
Okay,
bar has been shown. So
okay.
this is the data of, I think,
I thought this is the building kind of thing,
no,
no?
not building.
Okay, this is the data.
Yes, yes. The way here the color intensity is showing the magnitude of temperature. Here the bars
Okay,
are showing the magnitude of the quantity measured.
okay, okay.
So this is called as the bar graph represented over the map. This is another one where the pie chart is represented over the map. So uh, this is also a choropleth graph. Here you are seeing the San Diego housing median home value by zip code. So this is the like 8 lakh dollar is the median home value for this color. So this choropleth graph is overlaid with the pie chart. So pie chart is showing how much the homes are actually occupied. So here the color is showing renter occupied and owner occupied. So pie chart is showing how much the whole houses in particular region are occupied by owner and how much is occupied by the renter. At the same time, The same map is representing the prices of houses or the value of the houses in different regions of USA. So these are the different methods how the geographically classified data is represented. Significance, we have discussed what is the significance of geographical classification of data. Now we are coming to qualitative classification of data. Here, it is not the time when the data has been collected or not the place from where the data has been collected, but the quality of data itself is the basis of classification. Like we have discussed before, the classification of fruits like banana, mango, oranges, and so on. So banana, oranges, all these are actually quality measured on nominal scale, and that is becoming the basis of classification. Like here in this particular, we are seeing that A plus, B plus, O plus, or AB plus, these are the quality of data itself, and that is becoming the basis of classification. So qualitative classification of data involves grouping of raw data on the basis of attributes or qualities that cannot be measured numerically. If it can be measured numerically, then it will become quantitative. If it cannot be measured numerically, then it is qualitative. Like A plus or B plus, it cannot be measured numerically, but can be observed and categorized. Categorized means different groups can be found based on that. Like A can be grouped as in one group, A plus in one group, B plus in another group, O plus in another, and so on. So it answers the question like what kind rather than how much. Okay, if it is asking how much, then it is quantitative, and if it is asking what kind, then it is qualitative. The key characteristics are based on it is based on non-numeric characteristics used when data is descriptive or categorical, useful for grouping people, objects, phenomena by types, kind, or quality. Usually presented in frequency table or pie charts. So, one example we have seen the fruits example. Another example could be the production of different cereals in particular state of India. Suppose Haryana. So in Haryana, how much the millets are produced or different kind of millets can be the different category. How much rice is produced and how much wheat is produced per year. So the, these wheat, rice, and millets can be different categories. And based on that, the overall production of cereal can be classified. Another so we can see there can be two type. One is the simple classification. Just we have discussed all of them are simple classification, and there is manifold classification. Manifold means you are taking two attributes at a time while you are classifying the data. Example is given here. The male employed can be one category, male unemployed can be another category, female employed and female unemployed can be other different two categories. So here we are taking two qualities at a time for classifying the data, then it will be manifold classification. Okay, actually table is also called as simple table for simple classification and manifold table for manifold classification. So if you are taking two or more qualities at a time for classifying the data, then it is manifold qualitative classification. Here is example based on the blood group. Another is based on the occupation, like occupation of individual in a particular district or maybe in a particular mohalla. The farmers are 40, teachers are 25, doctor 15, and engineer 20. So it is non-numeric attributes are used for classification here. So why is qualitative classification important? Helps in organizing descriptive data for better analysis. Enables comparison between different groups. Like we can compare here how many are farmer. For example, in this particular group, farmers are maximum in number and doctors are least in number. So comparison is possible in different categories, and the data has been organized. Useful in sociological, economic, and demographic studies. So I guess you can see one example of sociological studies can be the one here, like male unemployed, female employed, and female unemployed. So suppose you are collecting the data based on, you are classifying the data on this basis, as well as suppose um, for the reasons. So you may find the reason where women empowerment is better, the female employees will be better in number, and where the women empowerment hasn't happened that to that much extent, you might find male employed persons more as compared to the female unemployed. So this kind of classification will give you some sociological indicator. Similarly, economic indicator and demographic studies also. You know, whenever census happens, different kind of information we used to get about the demography of a particular region. Now we are coming to quantitative classification of data. That means the magnitude or quantity of the individual are itself becoming the basis of classification. Definition, we can read it. Quantitative classification refers to process of grouping data based on measurable numerical values. Here it is number, the amount is becoming the basis of classification. It organizes raw data into class interval based on quantities like height, weight, income, marks, temperature, etc. It answers questions like how much, not how, or how many. How much means measurement, means continuous data. How many means the integers or the discrete data, or what is the value. Key features, data is measurable and numeric. Groups data into class interval or ranges. Each class has frequency suitable for continuous and discrete variable. We'll see with example. Types of quantitative classification. Types of quantitative classification based on can be discrete classification. As we discussed while we were discussing the types of data, when we were discussing the types of data, we discussed qualitative, quantitative, and in quantitative, we saw discrete and continuous. So, discrete data is always represented in whole numbers, like number of family members, okay, 1, 2, 3, 4, and so on, like number of leaves in a plant, like number of fruit a plant bears. Okay, so these are the discrete data, and based on that, it will be classified. Then there is continuous classification for continuous data, and these are represented by range or class interval, like height of students from 140 to 149 centimeter, 150 to 159 centimeter, etc. Why we use quantitative classification? It makes large numeric data comprehensible and analyzable. We will see with example. Helps identify distribution pattern, useful in constructing frequency distribution, histogram, and statistical analysis. This particular part, useful in constructing frequency distribution, histogram, and statistical analysis. This you will study in upcoming lectures, because most of the statistic which you will deal will align with the quantitative classification. Moreover, most of that will be uh, around the continuous classification. So not much of that example we will see. We will see only the introductory part. Rest you will see in the upcoming lectures. Uh, Let me show one example here. Data series we will discuss later. Like one example here, you are seeing the example of discrete data. Here is you're seeing that Rahul has got 45 marks, Meena has got 38 marks, Zoya 50, Karan 41, and Anil 46. This is very simple um, data. Actually, you can't see that it has even been grouped. Okay, and such series is called as actually individual series, where there is no grouping. Individuals are given here in column left column and the marks in the right column. Actually, the table of 100 points which we saw in the very beginning was also kind of individual series. However, it was not series because that was not organized. Now see the discrete series or frequency array. Here, this table is showing the number of books read by number of students. Like there are 2 students who have read none of the books, 4 students read 1 book, 6 students read 2 books, 3 students read 3 books, and 1 student read 4 books. So here you are seeing the basis of classification is the number of books read. And number of books read is itself a quantity. And this quantity is becoming the basis of classifying the students of a particular class. If we'll sum it up, then it is 16 students. So these 16 students has been classified into 5 groups. Total number of students are 16. And these has been classified into 5 groups based on what? Based on another quantity. And then that quantity is number of books read. So quantity is becoming the basis of classification here. And that's why it is quantitative classification of data. Now, this kind of series is called as discrete. At the same time, we are trying to condense and simplify the data. Similarly, there are 10 students which are having their heights between 150 to 159, 18 students which are having their heights between 160 to 169, and so on. So, for continuous series, the data is grouped into a class interval or ranges. Range is not good term here, but we are using because we are in the beginning. Class interval is good term because we are in the continuous series can be of two type: exclusive series or inclusive series. You can see here that the first class is 0 to 10 and second class is 10 to 20. So we are seeing that upper limit in a 10 to 20, the lower limit is 10, upper limit is 20. Here lower limit is 20, upper limit is 30. Here 30 is the lower limit and 40 is the upper limit. What we can notice here that the upper limit of the first class is 10 and lower limit of the second class is 10. Okay, that means the boundaries or limits of the two consecutive class are actually overlapping. If this, there is such condition, then such series is called as exclusive series. As the definition says, in the exclusive method, the upper limit of a class does not belong to that class. It is excluded and included in the next class. What does it mean? It means that 10 is not included in the first class. It is actually written marks. Let me write it height, or maybe weight in kg, and let it be number of students. Why I'm doing so? Because sorry, because it is for continuous series, and marks can be continuous, but usually, marks are given in discrete. Usually we give marks 1, 2, 3, 4, 5, and so on. We usually don't give marks 4.1 or 4.2 like that. But weight can be in points, in decimals. So 10 are here, then 10 is in the first class interval as well as in second class interval. Suppose a student has 10 kg weight. So whether that student will come in first class or the second class, this is the question. So answer is, the student having their weight 10 kg will fall in the second class.
Sorry to interrupt, sir. We
Yes.
have 10 more minutes
Okay.
to complete the
Okay.
lecture.
Okay. Thank you. So here we are seeing that the 10, however, the 10 is written in the first class interval, but it is excluded there. The student having 10 kg weight will fall in the second class, but not in the first class. So the upper limit shown in the first class is actually excluded. Similarly, 20 mentioned in the second class is actually excluded. That's why this kind of series is called as exclusive series. And the series, this kind of series is called as inclusive series. Here, if 10 is written as upper limit, that means 10 is included in the first class. And the second is actually, second class begins with the 11. So 10 will always come in the first class and second class will begin with 11. And it will end up at 20. So this kind of series is called as inclusive series. So again, I want to summarize here quantitative classification. Quantitative classification has individual series where actually no condensation is happening. Only the data is arranged in certain order. Then we have discrete series where actually the data has been classified, but there is no range or no class interval. For continuous series, we are seeing that there is class interval, but it can be exclusive or inclusive series. In exclusive series, the upper limit doesn't include that individual of particular class, but in inclusive series, the upper limit includes that individual having that magnitude of attribute. So this is all we have covered in the classification of data. As far as the representation of quantitative data is concerned, that you will study in detail while you will study the representation of data. You will study frequency polygon and bar diagram, different kind of bar diagram, and you will see frequency curve, cumulative frequency curve, and so on. All that is related to the quantitative data. So that's all from my side. Thank you. And you may ask the questions you have.
Thank you very much, sir. It was an honor to have you to share your invaluable insight on classification of data. Your presentation was truly engaging and thought provoking, and we are incredibly grateful for the time and expertise you dedicated to our event. Now, we encourage all our participants to take this opportunity to ask any question or share their queries with our speaker. So now you can type your question or query in the message box or in the comment box of the YouTube. So let me see, is there any question? Right. Yeah, I have received some question on my WhatsApp as well. I will ask that. Yeah. Meanwhile, I am checking on the YouTube. No, there is no question on YouTube. So, okay. So the first question was asked by from our one of our participant. Is there any difference between tabulation and classification of data?
Okay. Yes, dear participant, tabulation is actually preparing the table. As I mentioned in beginning of my presentation, that classification goes with tabulation hand in hand. So classification is actually deciding the basis of grouping the data, and then you are taking the data out of the raw data and putting, while you are doing the classification, you are putting it into uh, the different cells of a table. So tabulation is kind of the very first method of the presentation of data after the classification.
Okay, sir. So the second question is that why do we need to classify data when computer can analyze data without classifying them?
Computer also classifies the data. Then it does the classification, or and you many times we used to give classified data itself to the computer before giving it for the classification, or you will tell what the kind of command you will give about what kind of inference you want to get from the raw data by the computer. If I, though it may not show that how is.
Okay. And one more question is that how to decide how many rows or columns should be there when we are having a big data? Like, should we divide the class interval in 10, 15, 20? What is the limit of that? Minimum and maximum.
So see, tabulation is done when while you are doing qualitative classification of data, or you are doing the quantitative classification of data. And one, we can take few example to deal with this question. Suppose you are classifying the data based on the timeline. It depends on your objective and the resource you are having. Resource means the time you are having, and the kind of the man force or the computer. Right now we have the computer, it can deal with the large amount of data. And and the objective, suppose if you want to see the certain trend over different decades, then you will put the decades as the class interval. And if you want to see, suppose if you want to see whether you should go uh, by by some vehicle, or by metro or by bus in the next week or not, then you would be looking to classify the rainfall based on the days. Okay. And if you want to see, if you want to book the train for the next, this is one basis, while we are classifying the data on the basis of temperature. Similarly, we have discussed a lot how the data is classified geographically. It depends on your objective mainly. And as far as the class interval is concerned, again, it depends on uh, how much resolved information you want to get. Suppose you have the data of the whole country, then you will put it in large bins. You will make class interval uh, bigger. It also depends on the range. Suppose you are classifying maybe the mosquito population in different maybe districts of the country. So there may be some districts where there is no mosquito, and there may be districts which are having very huge amount of huge population of mosquitoes. So accordingly, you will keep the and depending on what kind of data you want to include in your analysis. If you want to even include the mosquito population of 1 meter cube, then you might want to include that. You will begin with that as the lower limit of the lowest class, and the highest population you will keep as of the upper limit of the highest class. Decide the number of classes depending upon the resource you are having, means what kind of analysis you want to get, how much resolution you want to get, and how much analysis you want to do. Suppose you want to have rough idea, then you might want to create only 10 classes. And if you want to have detailed analysis, then you might want to get more number of classes.
Thank you, sir. There are some questions in the chat box. In Atif Siddiqui is asking, in complex data set, how do we correctly classify a variable that exhibit both qualitative and quantitative characteristics like educational level or income brackets?
Yes, for that educational labor, and I just told you that there can be manifold classification. I give one example: men employed and men unemployed. So you can prepare manifold, you can do manifold classification, and you can prepare manifold table for accordingly.
And the last question is from Kumari Shona. Sir, can we use numerical value to describe the nominal data or qualitative data? As in the given example, we have seen the fruits with three count which are numeric value.
See, for nominal data, if you can give numbers, but number doesn't hold the quantity. Like you are numbering students, suppose students are standing in a queue, and you are numbering them as 1, 2, 3, 4, 5, and so on. So here, one doesn't mean that it is one and the
Yes, yes.
yes, and it can be ordinal also. Like you are numbering the one which is standing in the front as number first person in the queue, then the second person in the queue, then the third person, then it becomes the ordinal data. And if you're randomly labeling them as 1, 2, 3, 4, and 5, suppose you just you are doing the surgery of certain organism, and you label different organ as 1, 2, 3, 4. So here the 1, 2, 3, 4, though it is numerical value, but it is showing the nominal data. And if you are arranging persons standing in a queue as first, second, third, and fourth, and so on, then it is ordinal data. So numbers can be given, but you need to understand the nature of information it is providing to you.
Yes, sir. I think that's it for today. Let me cross check it twice. Yeah. No more questions, sir. So thank you very much, sir. Eh, on behalf of the organizing committee, now I take this opportunity to express my heartfelt gratitude to all those who made this event a success. First and foremost, our sincere thanks to Dr. Anurag Maurya for gracing this occasion with his presence and sharing such valuable insight. We are truly honored, sir. I extend our deep appreciation to our principal, sir, Professor Narendra Singh, whose guidance and constant support made this program is possible. To the IQAC coordinator, Professor P.K. Sisodia, and the bursar of the college, Professor Mukesh Jain, thank you for your constant support and guidance. I also acknowledge the constant effort of the convener, SDCC Dr. Saima, and fellow colleagues Professor Dheeraj Singh, who ensured the smooth conduct of the session. A special thanks to all the participants who registered and shown such enthusiastic engagement. Your presence is what gives meaning to this course. Last but not the least, thank you all once again for being with us today. We look forward to continued learning, collaboration, and success throughout the course. Thank you, everyone. Please mark your attendance in the message box. And if you have missed your first feedback assessment form, make sure that in future you will not miss it, because the certificate depends upon whether you are getting 80% of marks in those assessment or not. If your marks are less than 80% and attendance are less than 80%, then providing certificate will not be possible for us. Thank you very much. Yeah,
Thank you, sir. Thank you for organizing today.
thank you.
Can I leave now?
Yes, sir. Yes, sir. Thank you.
Thank you. Thank you so much.